Hello, everyone. Welcome to the very first edition of the Africa Share and Discuss webinar series for 2023. Welcome to the new year, and we're excited to have you join us again. I hope you all enjoyed a very pleasant break from work or holiday, and as excited as we are to start the new year and also having you started with us. Thank you for joining us. We'll allow for a few more seconds for everyone to join in and get started, after which we will go through the daily rounds, just so a very brief intro, then introduce our very first speaker for the year. There you go. Okay, I'll share my screen and we will be on our way. We're 2 minutes in, but that should. There you go. Sharing my screen and we will get started. Awesome. So again, welcome everyone to our very first edition of 2023. Okay, some technology glitch. So welcome, just like I mentioned, my name is Shola Olateju, and I'm excited to have you join us. Welcome to the PhET Africa Share and Discuss webinar series. We meet every third Wednesdays of the month to discuss PhET simulations and how that can improve our practice, but also have seasoned speakers who have used PhET simulation either in practice or in research come to share the best practices they've learned and how that can help improve our practice in our classroom. We're excited to have you join us today. And over the past month, we've had various speakers, which you can catch up with all the recordings from the previous sessions on our YouTube page. If you visit YouTube and search for PhET Interactive Scenes, you'd see the recording of all of the past sessions. So we welcome you to connect and share widely as well with other teachers who might not be able to join us live on the session. For housekeeping rules, we have saved time for question and answer. So while today's speaker is sharing, we will not be taking questions while the session is on. So please, we encourage you to use the question and answer feature here in Zoom to drop your questions. We would also have a couple of our speakers or our attendees joined via Facebook. Please use the question and answer feature on Facebook, and we'll be paying attention and bringing your questions to the attention of our speaker. Lastly, before I introduce the speaker, I cannot go on without mentioning our community on Facebook, where we have, of course, the PhET team, as well as some of our speakers, and a large community of users of PhET on the continent come to have their questions answered or connect and support others in improving the effective teaching of mathematics and science on the continent. So we welcome you to connect and continue the conversation there, because often an hour is never enough to address the conversations we have here, but this is a good place to get it started, and we can continue those conversations within the community. So today, without further ado, I have the pleasure of introducing our speaker, Marianne Good, who is a physics lecturer from the University of KwaZulu-Natal, South Africa. Today, she's going to be sharing on the possibilities for teacher education practice. She's going to share extensively about her experience using PhET simulations in teacher education program, especially in remote, both online and contact sessions. We're excited to have you, Marianne. Thank you for joining us, and I will hand control over to you now. You're welcome, Marianne.
Hi, Sarah, and good afternoon, everybody.
Good afternoon. So would you like to start with a brief introduction? I'm going to stop sharing my screen now, so you can, my slides, sorry. Just a minute. Stop share. Yes, please share and we can get started.
Okay, now let's do that. Okay, as Solid said, I'm a physics, in fact, education lecturer at the University of KwaZulu-Natal. So I work, sorry, I'm just trying to get that there. There we go. So I work primarily with pre-service teachers. Let me just make sure this is, yes, there we go. Okay, so this is a little bit about my teaching context. I've been in teacher education since 1994. So I'm an old hand at it. You might have guessed that from the hair color. And I've been using PhET since 2010, in fact. As I said, most of my teaching is done within our Bachelor of Education program, which is a 4-year professional qualification for teachers. And in this program, students don't only do education, but they also do the content and the methodology for their teaching specializations. I don't teach methodology though, or pedagogy. I teach content specifically and physics. And I do this with teachers who are either specializing to teach natural sciences in our grades 7 to 9 or physical sciences in grades 10 to 12. So that's a little bit about who I'm working with. Prior to COVID, so pre-2020, all of my teaching was contact in a lecture venue, but I had access to laboratories. So my students could go to the laboratories to do practical work, but also I was able to take equipment to my lecture venues to do class demonstrations. During COVID though, we shut down completely. And in fact, up until the end of last year, all of my teaching has been online, and that includes practical work. And most of it has been asynchronous, and that has had an impact on obviously how I've been practicing and how I've used PhET over the last few years. So how did I start off? Well, like most teachers, I started off small. I started off by identifying a few PhET simulations that would be useful to use for demonstrations in my lectures. And I was looking specifically at those that I could use to help students visualize phenomenon, because I really do believe that when students see something, it becomes real to them. When they just hear about it in class, they might go and memorize the ideas, but it doesn't become part of their way of thinking and belief, and part of their belief system. And the purpose of this is really to help develop their conceptual understanding as well as to increase their motivation. And some of the simulations I adopt for that are the bending light simulation. That is really nice for not just demonstrating refraction of light, but also phenomenon like dispersion and total internal reflection and critical angles. They can all be done quite easily with that simulation. For color vision, brilliant for illustrating color mixing, additive color mixing, as well as the effect of filters on light. Energy changes with the energy forms and changes simulation, and gravity and orbits for simply showing students that our orbit around the sun is not actually perfectly circular, but is in fact elliptical. So I've used all of those as aids in my teaching. Now you might wonder, why don't I use physical equipment in some cases like for light? I do try and do that where I can, because I think seeing the actual equipment is important, but there are some situations where it's just not feasible to actually bring equipment into your room. Maybe because it's a very bright room, maybe you don't have electricity, maybe you don't have equipment. Or in my case, I have very large lecture classes. Another use is to help students visualize proportionality. So when teaching electricity, you can use the Ohm's law and resistance in a wire simulations to show how changing one variable impacts on another. So those of you who haven't looked at those, you might want to go and explore the use of those two simulations. Another use is in predict, observe, explain, or PoE activities. And the purpose of these are to simply identify students' misconceptions or alternative conceptions related to particular topics you're teaching. And one of my favorite tools for this is the circuit construction kit. And I'll show you 3 activities that I actually do. And the purpose is to stimulate students' thinking and engagement, again, focusing on their conceptual understanding in line with a constructivist approach to teaching. So one of the first activities I do with students is this one, asking them how much do they know about circuits, asking them to predict which of the light globes illustrated here will actually light up. So they have to make their predictions to say, yes, it will, or no, it won't. They then share their predictions. I record that. And then we actually use the simulation to test this out, because using actual equipment, physical equipment, is not practical with the numbers that I've got. And then we see what actually happens. And it might surprise some people to know that while most students get A and B correct, C, D, E, and F are not actually as easy for students to predict. Many students actually get the predictions wrong. And so by doing this activity up front, it confronts their idea of what a closed or an open circuit is and leads into the discussion of that topic. When you're doing circuits, in the South African context, most of the learners I teach have done or studied electricity and electric circuits at some level, usually at natural sciences, but a lot of them have learned rules, but they don't really understand how they work. So while they know, for example, that globes in series all have the same brightness, when it comes to comparing circuits with different numbers of identical globes, they're not so good at doing that. So, for example, in the parallel circuit one, when they're predicting the brightness of the various globes in that particular setup, most of them do not know that all of those globes will have the same brightness. Okay, and this is something that once we've discussed their predictions and we've recorded what the different ideas are, we test it out, we see what the actual behavior of the circuit is, and then obviously that leads into a discussion of what is actually happening and where their thinking might actually be faulty. So that I do with natural science teachers. Another use on a small scale is for demonstrating what I've called here dangerous phenomenon, but just making students aware of safety issues in relation to science, making them understand and appreciate the dangers of certain actions they may want to take. And again, it's focusing on conceptual understanding. And these are simple ones that you could incorporate probably in your own teaching if you don't already do that. So what will happen if you throw an empty spray can into a fire? These cans come with warning signs not to do this. And I know one of my students said to me, oh, they used to do this as children. They used to love throwing empty cans into a fire. And I pointed out he's very lucky nobody got hurt. So you could use the simulation to show your learners why this is not a good idea. Another one in relation to electric circuits is, of course, the idea of short circuits and short circuit currents, making them aware of what the possible consequences of a short circuit might be. So those are just two ideas that I've used in my class. I'm sure some of you have your own ideas or favorites that you like to use in your teaching context. Now, this use is a little bit more advanced. This is what I call an interactive demonstration lecture. And in this, the simulation is actually the focus of my entire lesson on a particular topic. And I do this to help students visualize the phenomenon that we're talking about and to explore it. And it's more of in line with an inquiry-based teaching approach, but again, focusing on developing conceptual understanding. The first one I did this way was the photoelectric effect. This phenomenon, it's not feasible to try and teach this with apparatus. If you've seen the apparatus for photoelectric effect, only one person can really work with it at a time. So the simulation is brilliant. So when I'm talking about photoelectric effect, I have the simulation showing it. I display it with my projector and I show them what photoelectric effect is. So we see that when you shine light on the metal surface on the left, electrons are emitted. And then we discuss what happens when you change the frequency or wavelength or color of the light. What happens when you change the intensity? And then we explore every aspect of photoelectric effect through the use of the simulation. And only when we've seen what happens and we've discussed what we would expect from wave theory, do we would then go on to discuss what Einstein's particle explanation is all about. Another favorite of mine is the wave on a string simulation. So I use this to teach about the properties and characteristics of transverse waves and pulses. And this screenshot over here was from a lecture that I did where we were looking at a particle in the medium represented by where this dotted line is here, this vertical line is on the screen. And we were looking to see how the velocity, in this case, of these particles vary over time, because our students are supposed to understand the motion of individual particles in the medium. And so I use the simulation to actually demonstrate for them what happens. Another one I've started to use lately is the charges and field simulation for teaching about electric fields. So many of my students in the past had not actually done physical sciences at school, so they do not know about electric fields at all when they come into my class. And so instead of doing what happens in many schools where teachers, they basically give the definition of what it is, and then they start drawing electric field patterns on the board. What I do is I take the simulation, and then we place in this case, I've got a positive charge sitting there, and then we drag the sensor represented by the yellow dot into the space around the field, and this red arrow shows the direction of the electric field. And then the relative length of that also gives an idea of magnitude. In this case, this is also from a Zoom lecture, so I was able to annotate and record the direction of the sensor at each point. And from that, we then build up what that electric field pattern looks like. And of course, once you've done it with one charge, I then give them an activity where they can actually explore electric field patterns for combinations of charges. Another one that I find very useful is the circuit construction kit AC, because in my electricity module, students do learn about AC circuits. And this is something that is very abstract, particularly if you're looking at the relationship between current and voltage for different components. So the screen here is from a lecture I was doing we were looking at resistance, and here the voltage and current are in phase with one another. So I was using the simulation to actually illustrate that for learners. Okay, so in these examples, the simulation is the basis of the entire lesson. It is used throughout to explore and discuss the phenomenon. Now, on top of using PhET simulations for developing conceptual understanding, they're also a tool, obviously, for doing investigations. And for me, because of the context that I'm in, so not just the type of teaching I've been doing, but also the students that I work with, I use them for guided investigations. So the students get very detailed instructions about what to do. Now, the reason for this initially prior to COVID was because most of my students come from schools where they don't have access to prac equipment. So many have never done an experiment themselves. So to bring them in and expect them to do inquiry type investigations on their own would just not be practical. It would not work. It would be a disaster. So I give them guided investigations to try and teach them or train them how to actually go about conducting practical work. And this is something that I have expanded on greatly during COVID, because during COVID, as I said, all my teaching was online. So my students were not on campus. They didn't have access to laboratories. So any practical work that they were going to do had to either be using videos, homemade equipment, photographs, I've used that, or PhET simulations. Initially, when I started, it was really to get them to explore concepts, explore relationships between variables, explore how systems work, and also, again, helping them to visualize concepts and ideas. But during COVID, it became more than that. It became an alternative to a hands-on laboratory experience as well. These investigations can be qualitative or quantitative, or a combination of both. So prior to COVID, I developed at least 5 different activities using the simulations you can see on the screen there. But during COVID, that expanded, and I was very grateful that the PhET team were developing new simulations like balancing act, like geometrical optics, and projectile motion. Those were all ones I was very happy to see coming up. What was it, 2020 or 2021? Now, on top of using simulations just to do guided investigations and to explore phenomenon, during COVID, as I said, this was one of the few ways that I could get my students to engage in practical work. So what I started thinking about was, how can I use these simulations as a tool for developing science process skills? Now, you can't develop all process skills through simulations. So students need obviously to get their hands on equipment to, for example, learn how to use instruments, how to set up equipment like ripple tanks and things like that. You can't replace that with an online experience, but there are skills that can be addressed. So I've listed some of the ones here that I've been trying to focus more on, starting with a really basic thing, just reading, interpreting, and following instructions. My experience of working with students on campus in labs is that if you give them a report sheet to fill in, they want to take the report sheet, manipulate the equipment, and fill in the report sheet. Many do not want to read the instructions to see what it is they're supposed to do. So these activities, hopefully, we're training them to read carefully, understand, interpret, and then follow exactly what they are supposed to be doing. And then PhET simulations, obviously, they're visual, so you can make visual observations. So they don't replace experiences where you get to touch and smell and hear, although some of the activities do now have sound, but you can at least make visual observations. And then, of course, students get to identify variables, they get to collect and record measurements. And with that, I'm trying to train them to look at uncertainty in measurements, and something they find very difficult. And then, of course, they get to analyze data. One of the ways is by drawing graphs. And the advantage of PhET simulations is that when they draw a graph, they are all using should be using correct data. Some of my students still manage to get faulty data. And then they can identify relationships from graphs. They can do mathematical modeling and obviously practice drawing evidence-based conclusions. And I've used a number of different simulations for that. For the mathematical modeling one activity, I use the balancing act one. So there I get them to actually discover, if you like, the law of moments for themselves. And that, in fact, these ones, balancing act, pendulum lab, and masses and springs, the activities I developed actually are all based on activities the students would have done on campus using actual physical apparatus. But during COVID, I had to adapt them for online experiences. And so those simulations came in handy. This is just an example of an activity I set at the end of last year. It was a long investigation. My students, I would give them a week in which to complete an investigation. So they would download the instructions. I would always encourage them to download the simulation, but I also provided links. They could then spend a week playing before they had to fill in an online report sheet. As has been pointed out by Martha, I think it was in the last presentation in December, it's important if you do an activity or use PhET that you understand why you're doing it. There has to be particular aims or outcomes you are aiming at. And so all of my activities start with a list of possible aims or outcomes. So I'm hoping that my students will start to think about why I'm giving them to do these activities. As future teachers, it's essential that they understand why we get learners to engage in different activities. And so I'm trying to get them to think about what it is that they are going to gain by actually engaging properly with this activity. So the ones that are highlighted here are specifically focusing on process skills that can be developed, but the ones now highlighted in blue, those are more conceptual. So understanding relationships, concepts, seeing the effect of varying different variables. Because they're online, I always give a diagram or an image here rather of what the simulation should look like when they look for it, so they can see the name and what it should look like. And then when they open that simulation, I also show them what the screen should look like. And for simulations that are a little bit more complex, as you can see here, I actually provide labels to explain what the different controls do. If I was on campus, I would actually demonstrate the simulation to the students before giving them an activity. But because it's online, I ended up doing it this way. So hopefully that provides some guidance. I think it was Martha as well who pointed out, although some of the simulations might seem very intuitive to people like me with a lot of experience, and I'm sure many of you, they're not intuitive for all our students. And I will show you a comment later that a student made. So I'm trying to provide some indication of how to actually go about using the simulation. And then notice here, requirements. So they need a laptop, tablet, or cell phone. Important here, during COVID, I only used HTML simulations. whereas previously I used the Java one, like photoelectric effect as well. But for student activities, I only used HTML simulations to ensure that every student should be able to access no matter what device they're using. And then I always recommend them to download the simulation and use it offline, not just because of data now, but because I tell them as future teachers, if they've downloaded it, it's a resource they now have that they can then use either during practice teaching, which our students do every year, or of course when they leave and as qualified teachers. This is just an extract from that activity. This is the first part, the qualitative part. So again, very clear, very precise instructions. It's guided. And then I give them questions to look at. So you can see for number 2 there, it's highlighted. I give them 2 multiple choice questions, trying to draw their attention to what it is I want them to observe. Obviously, if I was doing this with them in class, we would be discussing what it is that's happening, what they're seeing, and I would be directing them to what they should be seeing. But because it's online and they're working independently, I did it that way. This is a different part of the same simulation, the same activity. This is a quantitative part, so they're actually collecting data on temperature and pressure, and then they're drawing a graph to see what the relationship between temperature and pressure actually is. And in question 13 here, you might note, I'm trying to draw the attention to the different variables to try and identify what is the independent, what is the dependent, and what are the control variables. Again, this is something that for some of us, it might seem really obvious, but I find that many of our students here in South Africa and KwaZulu-Natal specifically, they struggle with this. Now, these are different ways that I've used it. And the key thing that I think for me, and something that I know has come up in previous seminars that have been held, is context frames how you use PhET. So my context has had enormous impact on what I've been doing for the last 2 years, and probably what I will go on to do this year, because our students will be coming back to campus. And so I have the options of taking to the lab or using PhET simulations. So some of the contextual issues that you need to think about when you're deciding whether or not to use PhET and how to use PhET is, of course, your curriculum. What is your subject that you're teaching? What is the concept that you're teaching? Who are you teaching? I really do believe that PhET simulations can be used from preschool all the way through to university level. You just have to adapt how you use it and what you want students to do. And then, of course, you've got to think about what is it you want students to achieve. So what are the desired outcomes? And then what will this PhET simulation allow you to do? Each simulation has what we call a number of affordances, so it will allow you to do particular things. Some simulations are only qualitative, some are also quantitative. So what is it you want to do? And then, of course, what are your students like? So what can they do on their own? And what can they do with scaffolding? And then where are you at? So what is your experience? Are you ready to jump in and do something more complex, or are you just starting out? And of course, where you teach. Are you teaching in a class, in a lab, in a lecture venue? That will have a huge impact as well. So all of these have an impact on whether or not you're going to choose to use PhET. And of course, when you're making that decision, you've got to think about, is it the only option I have? Is it the best option you have? And if the answer is no, you don't use it. You take the other alternative. If the answer is yes, then the PhET simulation is the best way to go. How do students feel about it? Well, just very quickly, because I know my time is up. This is just some of the student feedback that I've had from students in my module evaluations. Some of them are very obvious, but the one for me that is very important is the last one, is that the students said the simulations are very helpful, not just for this module, but also for us as future teachers. And really that's important for me as a teacher educator, is that I'm preparing the future teachers to go out and practice, and I want them to be able to use technology. And I do believe that the best way to teach them to do that is by modeling it and showing them different ways in which they can use it. So thank you, everyone. So I've probably gone over, hopefully not too badly, but thank you very much, everyone.
Thank you so much. No, you did not. I think you're just on time. So we still have enough time to allow everyone share their questions. So please, this is a good time. If you have questions or comments, please use the question and answer feature, and we'll get to it in a bit. Just to drop them, and if you'd like to ask directly, let us know, and we would enable your mic so that you can speak directly to our speaker. So thank you so much, Marianne. Like it felt like a speed drive through the use of PhET, and it's evident in terms of the experience you've gathered from the use of PhET simulations. But one of the things that struck out, so sorry, just so sorry. So one of the things that stood out, which I think you started with even before you went all the way in terms of all of the practices that we can consider as teachers in our classrooms, but also there are tips you share that is useful for teacher education stakeholders as well, that they can take into their practice. You start small, and I thought that was very important in terms of scoping the work that is being done. Some of the things you did amplify on that later on around the importance of context and all of those. But do you really, I would like to speak a bit more to that in terms of how would you advise teachers, especially from your experience transitioning from in contact or in person to online? What are the advice you would have for educators who are trying to embrace PhET in different contexts? What are the things they need to pay attention to avoid frustrations, perhaps things they might be doing wrongly that might end up causing perhaps some frustrations from frustrations further down the line? In your experience, how can they avoid any bottlenecks in effectively using this and avoiding the challenges they might face, considering some of the context you've mentioned as well, the class size, geography in terms of separation from or distance from the physical lab? So any thoughts around that would be helpful. Just a reminder, please drop the questions now and we'll get to read them out in a bit. Thank you. Please, over to you.
Thanks, Ola. Yes, I think why I'm emphasizing that is I think it can be very overwhelming to try to start a new technology, especially if like the PhET simulations, I've viewed some of the videos on the website about how they're designed to be used. And if people view that and think, oh, if I'm going to use them, I need to do inquiry-based teaching. I need to have these open-ended investigations with my students working on computers, then you're going to be frustrated straight away. Number one, because yes, we're not all lucky enough to have venues with multiple computers where we can teach, or classes that are small enough to do that with. Some of the schools that I visit for practice teaching, they don't even have electricity. So that is really not an option. So the thing is not to be intimidated and think that because they've been designed with that idea in mind, more for an inquiry teaching approach or open-ended inquiry, that's not the only way to use them. They are tools, and all tools can be used in a number of different ways. So the key thing for me is for teachers to think about how best a simulation, and start with one, a simulation can assist you to teach better or help your learners to learn better. So you have to spend time on the site yourself, firstly, playing with the simulations, and this point has been made previously by other speakers as well. You have to go on and explore. That activity that I showed you, that gases one, I have about 3 pages of scribbling. In fact, it might be 3.5 pages of scribbling, where I was just making notes about what can the simulation do? What kinds of readings do I get? What kinds of questions can I ask? So it takes a lot of preparation. So you've got to think about what simulation will help you to do something that you want to do better. So that's why I said as well, thinking about outcomes. What are the outcomes that you as a teacher want to actually achieve? So don't focus on what other people are doing. It's useful to learn from other people, but only you know your context. So you've got to think about what your context is like and what you can do. So for me, yeah, developing online pracs, it was quite a jump forward for me. They took an enormous amount of time to develop. And to be honest, now going back to contact teaching, I'm a little bit reluctant to lose all of them because of the effort put in to get to that point. But some of them are going to go because I'm going to go back into the lab. So for optics, I developed activities on optics using the geometrical optics simulation. It was the only thing I could do online. Going back into the class, I'm going to have my students going into the lab and working with optics kits. So I think just remember that there are different ways of doing things. There's no one right way that works for everybody and in every context. As a teacher or a teacher educator, you understand your context best. So you've got to work within whatever limitations you have. So whether it's your class size, the age of your learners, access to equipment, as was pointed out by, I think Zach pointed out in the last presentation, some teachers simply have their phone. And I've seen it with my students. They take their laptop to class and they bring learners up in groups to do demonstrations with them because they don't have a projector and they don't have multiple computers and their learners don't have smartphones. So I think that for me would be the key thing. Understand your context and use the PhET in the way that you think will best help you achieve the outcomes you're wanting for. Don't get too stressed about whether or not you think you're using it the way it's intended to be used. Thanks, Ola.
Awesome. Thank you so much. So you understand your context and find the best way to use PhET. So another thing you mentioned not long ago is related to teachers bringing devices to classroom. And we have a question here that says, learners need laptops for such activities, which is not in so many African countries. I don't know if you've had other experiences, but especially in your practice when you are online. I don't know, I would expect that many students would have had devices, but did you see what are the other opportunities for collaboration, or what patterns did you see in students who did not have devices to take advantage of an opportunity in spite of that, the challenge they might face regarding that?
Yeah. With online, when we went online in 2020, the university spent a large amount of time, as did many institutions in South Africa, trying to equip students with devices and data. So we probably had a bit of an advantage in that most of our students either had funding to get laptops and they were assisted in getting laptops, or a lot of them had smartphones. So a lot of our students work on their phones. They do everything on a phone, which I really take my hat off to them because I couldn't do it. I'll be upfront about that. I couldn't do that. So a lot of my students will work on cell phones. And that's why, as I said, I would use the HTML simulations because I know they work everywhere. And I would test it first on my tablet, because that's an Android device. So if it works on my tablet, it'll work on a phone. Prior to COVID, I would do one of two things. One of the practical activities, I actually used to do it as a laboratory in the laboratory room. So students would come to the lab and they work in groups. So I would ask in each group for one student to have a device, to either bring a laptop or a phone, and they would share. And then I would take my personal laptop and any other work laptops that I could scrounge, I would take them to the venue as well for groups who didn't have. So usually with our students, at least one would have an appropriate device, and they would work in groups of 4. I've also had a case where I had them doing an activity on capacitors, and I actually got them to bring their devices to the lecture room. And they were working on it in class. And again, they were sharing devices. But obviously, I'm working with students. They have these things. Zach did, I think, mention an alternative where you could give the students, maybe if they can use their parents' phone or something like that. But obviously, if you in a context where very few of your students or your learners have access to a device or to network, then your whole class activities would be best. And that was spoken about in the last presentation by Martha, I think it was. She was talking about that. So hopefully that helps. But again, it's about just understanding the context and what is possible, and just do what you can.
Yeah, thank you for that feedback. A couple of comments as well. Hi, Rose. Hi, everyone. Hope to get the recording. Yes, the recording will be available right after before the end of the day, so you can visit our page on YouTube to catch up on this session and previous sessions as well. And Josiah says, thanks so kindly, please for sharing your knowledge with us. Can we participate to make simulations like this? Yes, Mohammed, please get in touch. That's a different conversation. Because of our time, I would not be able to attend to that now. Kindly share the slide of this wonderful presentation. I had difficulties joining early in the network. Yes, please, you can get in touch directly with the speakers. With the speaker, email address was on the screen. But also, like I mentioned, the recording is going to be available, so you can always catch up on that now. And we always encourage that you share widely with your network. As specialists, we help in this work. This simulation can replace the work lab. Okay, I'll come back to questions quickly. I think we still have some time, about 10 more minutes to get to that. We already responded to the issue about navigating the obstacles that comes with the digital divide in terms of access to digital devices. Another question from Gideon is, can learners do such online activity in groups? Since most, a similar question, I think that has been answered as well. Yes, it's possible to collaborate either, that there are opportunities to collaborate and can design based on your context as well, your class size, all of that. You can design something that works for you. Professor Shumba is asking here that what can you share on addressing alternative conceptions with PhET sims? I don't know, would you like to speak to that? What can you?
Yes.
Okay, please go ahead.
Yes, I did touch on that. As I said, in science education, of course, we're very into constructivism. And so it's important that wherever possible, we do identify and those misconceptions up front. And so for me, as I said, the circuit construction kit, DC, is one that I use specifically for that purpose when I'm teaching electricity. I'm trying to think offhand which other ones. As I said, I've been teaching online for so long, it's a little bit hard to remember what I've been doing. But you know, there are. I mean, if there's a simulation where you can demonstrate a concept that is difficult for students and when you know there are alternative conceptions, then what you do is you just incorporate an activity into there, like those predict, observe, explain. And I think Professor Crick spoke about that last year as well. You know, you find a simulation linked to the topic you're teaching where you know students have problems. And if it will allow you to demonstrate that difficult concept, you know, think of a question, you know, from assessments. I mean, I love doing my own marking. I don't like having people help me with marking, because when I mark students' work, that's when I identify where the problems lie. And that's where I come to understand how they think about topics. And from that gives me ideas of the kinds of questions that I could use in class to elicit the different misconceptions. And which, yeah, if there is a PhET simulation that will allow you to address that or highlight the fact that it is actually a misconception, then it's a good thing to use. But it's not the only thing. I mean, obviously, if you've got apparatus to actually physically demonstrate something, that would be an alternative that I would certainly use as well. As I said, it depends whether there's a PhET simulation that can help with that. But I do think it's really important to incorporate those kinds of activities as much as possible in teaching, and at all levels. As I said, I do student teachers from first year through to fourth year, and they all have misconceptions. They all have some concepts that they don't understand as well as they think they do. So I don't know if that helps or if you want to follow up. Oh, sorry, you're muted.
Yeah, thanks for pointing that out. Yeah, so like I was saying, please, if you have questions, please feel free to write use the question and answer feature, and we'll get to that. Etienne says, good presentation. While we wait for more questions, I think we have Josiah, but I wanted you to speak briefly also to what you mentioned not long ago, student struggle, and how as educators we can perhaps show more empathy with helping students navigate issues around misconceptions or educators' perception about students' understanding of things that they might not find as intuitive as we might expect them to be. As educators, how do we often put PhET themes in front of students, and it's easy for them to find their way. But what would you advise for educators to look out for so that that gap between our expectation of students and where they actually are, we can harness and understand what the problems are, and then provide the right scaffold or support to get value out of it? But any thoughts alongside that, and how do we look out for that so we don't miss out on those learning opportunities?
Yeah. I think that the first thing is just not to make assumptions about students. In any class, you're going to get a mixture. You're going to get some who are more knowledgeable about ICT than you are. Certainly, that's my case. There's some things I don't work a lot with. I mean, at the start of 2020, I had not used WhatsApp at all. I'm still not on any other form of social media. So I'm not on the Facebook group, unfortunately. I had to learn. And, if there are things I needed to do, I asked my children, or my husband, who was an active user at that time. And you learn. And I think we've got to understand that our students are like that as well. Some of them, yes, they have access to smartphones, to the internet. Maybe they play games, so they're familiar with navigating controls and figuring things out. But there are some of my students, they come from rural schools, where, as I said, there isn't even electricity in the school, never mind network. So some of them arrive and they've never touched a computer before. And because I work with first years and I work with them even at registration with curriculum advising, and I help them with register, I'm very aware of that. So I would say I probably know my students fairly well, but again, as I said, I don't make assumptions that they're all the same. So while I acknowledge that some are very able and come in very prepared for what I want them to do, that there will be some. And the thing is just to be, as you said, you've got to be empathetic, and not judgmental. I found, when you accept students and you're welcoming and you're helpful, they'll open up and they'll share. If they need help, they'll ask. It's only when they think that, you're not approachable, you have these expectations, and if they don't live up to it, they're somehow going to let you down and you're going to hold it against them, then you'll have a problem. So know your students. Don't make assumptions. Always acknowledge that if they need help, ask. That's what I always say to students. There's no such thing as a stupid question. If you're in doubt, ask. And really, for me, that's a key thing. And so, as I said, even when I'm in person with the PhET simulations, if I'm going to use it for an activity, a prac activity, I demonstrate it in class first. So they see me using it and they see what the controls do. And then I'll help them, as I said, with accessing. And as I said, I do provide links. We have a learning management system that we've been working through called Moodle. So I do provide actual links there so they can actually use the simulation in our learning management system. But then I also try and tell them how to download, because for me, that's a key thing as well.
Okay, great. Thank you so much. I'll take your comments from Josiah and Slimani. Yes, Slimani, the presentation and the recording will be made available. Please get in touch with Marianne. Email perhaps would come up on screen again just before the end of the session. So if you'd like to connect, yes, please feel free to get in touch. But the recording is definitely going to be on YouTube in a couple of hours after the end of today's session. Josiah says, what advice can you give me in Liberia about PhET, where ICT knowledge is very low and computer lab is very low too? I'm just trying to introduce this knowledge, and how can I get it to sit down in the country? I think every country or every teacher starts at some point, and just like Marianne started, that's like your context, and it's okay that the reality is that's where they are. And it's a gradual step, perhaps introducing one scene to get them to help them see the difference with using such a tool, what the difference using such a tool can bring to their classroom is a good way to introduce it. But most importantly, by modeling and showing it is one way, but also having them try things out themselves, as in seeing once you've modeled, of course, perhaps on the phone or on your device, they can try out and then see how the cause and effect on the interaction they make and how that can have ripple effects, and they see the reaction of all their action is actually a very potent and effective way that can work. And those are like the quick way you can get started with just a quick demonstration. But I would advise that if you need help getting the team to set up perhaps a training or meeting to introduce PhET through perhaps a 1-hour introductory session, we'll be happy to help get that started and ensure that, of course, teachers in Liberia as well get comfortable with use, and then, of course, can grow in their knowledge and confidence in the use of technology as well as PhET. I think we've come to the end of our questions. Okay, Mama Kamise just dropped about 2 more questions. We'll just take that, and that hopefully that we might not be able to take much more. Instead of contacting Mary, why can't the organizers make the presentation available for us all? Unfortunately, we do not have such a platform now. We can drop in a Facebook community, but I think the best we will also want interconnection or relationship to build across the network. So it's okay to connect directly. If she shares with us, we can post in the group, but there's no platform at the moment where I would say this is where to pick it up from. How much would it cost to train colleagues in my school? We can talk about that later on, but most trainings across the continent at the moment will cost you close to nothing from us, but then there might be other logistics and things that might be involved. Once you understand the scope of what you're trying to do, we can advise and then help you bring the training into your institution or into your country or education district. Mama Kamise says, Josiah says, thank you again, Marianne. This is our last question or comment before we call it a day. Mama Kamise from Lesotho, I just joined due to traveling from work and home. I know the presentation was great, so I'll listen to it, just letting you know that the solution have been very helpful, and my colleague, blah, blah, blah. Okay, thank you so much for the feedback, Mama Kamise. And we're grateful that, of course, you're starting the year with us. We're excited to continue bringing, of course, experienced users of PhET and amazing teachers on the continent like Marianne to continue to share their experience and inspire many of us to improving the teaching and learning of maths and science on the continent. We've come to the end of today's show. I would allow Marianne perhaps just give a final comment before we call it a day. Any final comments, anything you'd want everyone to know? I don't know, perhaps your email again, if there's anything you want to just leave with everyone.
My email, certainly, yeah, it's very easy, goodm@ukzn.ac.za. So please, anybody, you are free to contact me. I'm very happy to share the slides. I have no problem with that at all. Or if you would like copies of anything to see how I set up activities or anything like that, please feel free to contact me. And in terms of, starting, as I said, just start small. Start with what you've got, and then you build up from there, but start somewhere. Thanks.
Okay, great. Thank you so much. So I'm going to drop the copy of the presentation in the Facebook group, so you can pick it up from there. Once the video is ready, perhaps in a few hours after the end of the session. So thank you once again, everyone, for joining today's session. We are always excited to have you join us. We look forward to having you again next month, same time, where we bring you another amazing speaker to share their experience. And of course, if you've had amazing experiences using PhET and you'd love to share, please feel free to get in touch with the team. And we'll be happy to arrange a session for you so that you can share your amazing experiences and how that can improve the practices of science and math teaching and learning on the African continent. Thank you so much once again and bye for now. See you next month.